Hi, so in this video I'd like to talk about the Tabulate library. Now as usual, the Jupyter notebook that I'm going to build up here is available in the GitHub repo. It is fully annotated and it is linked below in the description of this video. So before we start, one thing that I want to do is I want to change the way that Jupyter wraps the output of my cells. And the reason for that is we're going to be working with tabular data essentially with lots of columns, and it's not going to fit right along on the width of this screen. And when I print data out that doesn't fit on the width of the cell, by default in my settings for Jupyter, it's going to wrap the text. And that's going to mess up all the kind of alignments that I'm going to try and do with the columns in this CSV file that we're going to use. So I'm going to turn that off. So I put that basically as, at the top of my notebook, and that's going to stop that from happening. So the Tabulate library is very useful and a simple to use library for generating tabulated data in a variety of styles. And it's not just presentation like display styles in the console. It can actually be used to generate tabulated data for other systems like maybe markdown or HTML, and we'll take a look at those later. So documentation for the Tabulate library, I have a link to it in the notebook that's in the repo. And of course you'll need to install Tabulate. And you can choose to install the library but skip the CLI. But basically you're just going to pip install Tabulate, or if you're using pipenv, I have it in the pipenv file for the repo. Otherwise, install it, with whatever system you use to install libraries to your virtual environments. So for this video, I have a CSV file that I obtained and slightly modified from the World Bank, and I have the link to it in the notebook, but I modified it slightly. I removed some columns and cleaned up a few things. So the file is located in the same directory as this notebook in the repo, and it's called population.csv. So let's take a look at a first few rows of that file, and I'm going to copy paste the code from the notebook. Basically, I'm opening the file and I'm going to iterate through the first 3 rows. I'm going to print that data out with just a little bit of formatting. And as we can see, we have the first row of the file essentially contains the column headers, the country name, country code, and then the years. And then we have the data itself. So we've got the country code, and then the population by year. And we have that for many, many rows. But I only printed the first 3. So as you can see, nothing lines up, right? It's just a CSV file. So we could try and display it in a slightly better format ourselves. Might be tempted to do something like this. We're going to import CSV, since this is a CSV file. I'm going to say with open, and then we're going to open population.csv and as f, and then we're going to create a reader. So we'll say csv.reader. So now essentially we have an iterator over the records in the CSV file. Each of those rows that comes back from that reader as we iterate is going to be a list of the elements in the CSV file, in that particular row of the CSV file. In particular, the first row is what? It's the headers. So I'm going to actually create a variable and read that row right into it. So I'm going to do a next on the reader to get the first row. That's the headers. And then the rest is really the data. So what are we going to do? Well, maybe what we can do is put a tab in between, right? So this row here is a list of these things: country name, country code, 2010, 2011, the column headers. So I'm going to try it this way. I'm going to use a \T for a tab, and I'm going to join, the headers. If I can spell it right. And then what I'm going to do is I'm only going to do this for the first few rows. So again, I'm going to say for underscore in range 3. The underscore is just a convention to say that I don't care about the iterating, the iterator, the variable, the loop variable. So we just use an underscore, but there's nothing, there's no hidden meaning apart from that in Python. It doesn't interpret it as something special. It's just a regular variable name. So now, again, I'm just going to use a tab, and I'm going to join what? Well, I'm going to read the next row from reader, and I'm going to join all the elements of that. And then we're going to output that. Let's see what we get. So as you can see, it's a little bit better, right? We've got country name, we've got the country code. If you look at the line 1 and 3, then the code, doesn't quite align with, this is the population, doesn't quite align here. This country name is quite long, so it really throws everything else off, and so on. So basically using a tab isn't going to work. We'd have to be a lot more intelligent about it. We're going to have to essentially, and this is what Tabulate does, we're going to have to load the entire file in memory or iterate through it at the very least and see what's the longest country name. And then that's going to be the minimum width of our column for country name, and so on. And then we have other issues that we would have to deal with. We'd have to deal with alignments. Well, how are we going to align floats? How are we going to align integers? How do we, test if something's an integer? Is the whole column an integer? Is it a majority of floats? So it's actually hard work to try and tabulate data. So instead, we can use the Tabulate library to do all that heavy lifting for us. So we're going to go ahead and then from Tabulate, we're going to import Tabulate, and we're going to import Tabulate formats, which we'll need in a little bit. So let's just import it right now. And now let's use it. So with open population.csv as f, we are going to use our reader, so csv.reader f. And then now that we have this data, so now what is this data? Reader is an iterator that's going to return lists, right? And so Tabulate is able to handle that. And the way Tabulate works is that it doesn't output, the formatted display to the console. It just returns a string that contains the formatted data. So it's a big string, but it's still just a string. So we're going to tabulate the reader in this case, which is an iterator, right? An iterable essentially, or iterator of lists. And that's going to now be a string. Display data is just a string. So now let's go ahead and print it. And you should use print, otherwise you'll see the \ns and so on. We actually want to print it. And when we do that, you can see that the output is much cleaner, right? We have these lines, I guess, that's supposed to separate the header from the data, but there are no headers. But what we know is a header is showing up here, so we'll have to fix that. We will really want this to be above that dotted line. And then you can see everything is properly aligned. The integers are properly aligned, the strings are properly aligned, and so on. So what we want to do is we want to essentially specify the headers. Now in this case, we're lucky because the CSV file contains already the headers, the column headers. So it's very, very simple to use. We're going to copy paste this code. And all I need to do here is specify an extra argument for Tabulate, which says headers is equal to, and then we just type the string first row. So it's just a constant string essentially that it expects here. And then we can print the data again. Now, as you can see, the output is changed. We now have the first line of what was our CSV file now is used as the column headers, and everything lines up perfectly. Now, if you have a CSV file that doesn't contain, let's say, the header row, or maybe you have a header row but you don't want to use it, then you can actually specify the column headers yourself and provide that to Tabulate. So let's go ahead and do that. So again, I'm going to take this code and we're going to tweak it slightly. What I'm going to do is I'm going to basically simulate reading a CSV file that doesn't have that first row. So what I'm going to do is I'm going to basically pluck out the headers. So I'm going to call it headers do.use, for example, and that's going to be next on the reader. Okay, so that's my reader. And then what I'm going to do here, I'm going to basically just go ahead and just read the entire file. So I'm going to do a list over the reader. So that's going to iterate over that iterator and then just return me now a list of lists. Okay, so now I have my data. If we want to look at what the data is, we could look, let's say, at the first few rows. You can see it contains a list of lists, right? Okay, so now that we have that, we essentially have data that doesn't contain the headers. So let's generate the headers. So we're just going to say headers is equal to, I'm going to use a list comprehension, and we'll say it's column I. So I'm going to basically provide I as 0, 1, 2, 3 for as many columns as we have in the CSV file. So we're going to say for I in, and now I want to, how many headers do I want? Well, as many as I have in headers do not use. Technically, I could just use, the length of any row in data. It doesn't matter. I'll just use this one over here. So I'm going to take the length of that. And so if we look at what headers are, you can see we just have column 0, column 1, column 2, etc. up to column 13. So now let's go ahead and use that with tabulate. So again, very simple. We're going to tabulate the data. And now instead of saying headers equals first row, which was just a string constant, we're going to provide it this headers that we have right here. And now you can see that tabulate used our custom headers as the column headers. Now we can also, if we want to, display a row index, like 0, 1, 2, 3, 4. And that's kind of built into tabulate as well. So let me go ahead and redo this code that we have over here, except I'm not going to skip the header row this time. So I'm going to take this out. I want to keep the header row, right? So basically I've read all my data into this, data variable. And let's go ahead and just use tabulate again. So we're going to tabulate data. This time I'm going to tell it that the first row in the CSV file contains the headers. And then I'm going to say show index. Show index equal to true. So when we do that, tabulate is going to automatically add this row number, essentially, this row index on the display, on the output. Now we can provide our own custom numbers for this. So that's very simple to do. We can do something like this. We can start with indexes equals a range. And I'm just going to create a big range. It doesn't cost me anything to create a big range since nothing actually gets computed until you iterate through the range. And what I'm going to do is I'm going to create a slice of that range. And so I'm going to take the slice because I need to provide the correct number of indices. Now I could have done it directly here, but then I'd have to calculate, well, I'm going from 5 in steps of 5. So where should I stop in order to cover whatever number of rows I have in the CSV file? And I didn't want to do the calculation. So I'm just going to create this range and then I'm going to slice it according to the length of the data. So len of data minus 1. So now I've got the correct number of indices. And if you want to take a look at them, we can take a look at the indices. Now, of course, if we do this, if we just print this out, then we're just going to get a range, right? We're going to get a range object. When we slice a range, we get a range object back. So if I really want to see what the data is in there, I can just make a list out of that. And I need to close that off. And you can see that we have the numbers 5, 10, 15, 20, 25, incrementing in steps of 5. And so now we can just go ahead and tabulate this way. So now instead of, I'm going to copy paste this, instead of just saying show index equals true, I'm going to give it my indices. Basically, that's all I need to do. And you can see now the output uses the custom row numbers, the custom index that we wanted. Tabulate also offers a wide variety of styles that we can use when generating a table. And this is where that tabulate format comes into play. So let's take a look at tabulate formats. It's basically just a list of strings. And you can see that we have things like fancy grid, fancy outline, and plain, and pretty, simple, etc. Those are kind of more display-oriented formatting. But take a look. You also have some other ones like GitHub, HTML, Jira, LaTeX, MediaWiki, and so on, even RST. So what's happening is that Tabulate can basically create the code that you would need to display this tabular data in that particular system. So if it's HTML, it's going to create a table, it's going to create headers, it's going to create rows and cells. So let's take a look at that. Let's go back to this one over here. and I'll take off the show indexes or show index. And instead, I'm going to specify table format, table FMT, that means table format. And let's go ahead and take the fancy outline, for example. And you can see with fancy outline, basically it's still a visual representation, it's still a visual display, nice display, but it's formatted slightly differently. You can also take a look at, let's say, maybe we can do the fancy grid. If you do fancy grid, what you're going to get now is the lines in between the rows as well, like so, right? Or if you just want grid, nothing fancy, then you can choose that, etc. You get the idea. Now, if we want to generate tables structured for systems like Jira or MediaWiki or GitHub or HTML or LaTeX and so on, then we just specify the appropriate style. So let's say we want Jira. We would just say Jira. And this is what Jira would expect a table format to look like. If you want to do Markdown, like GitHub Markdown, then you just use GitHub. And this is what the format would be for the Markdown. It still looks fairly visually pleasing, right? And that's the idea behind Markdown. But if you take a look at something like HTML, well, that's what you get. A little bit different, right? Now you've got this table, header, and so on. Now that's not something that's that easy to read. It's still, Tabulate still tries to line things up, but you'll see it properly lined up when you do it inside, when you view it as HTML. And then you have, of course, MediaWiki, you've got LaTeX, you've got all kinds of things that you can use. You can see if you're familiar with LaTeX, this is how you do tables in LaTeX. Now, Tabulate isn't restricted to tabulating lists of lists, which is what we've been dealing with so far. It can actually handle also kind of a wide variety of input formats. You can work, for example, with iterables of dictionaries, and it will use the keys as the columns from your dictionaries. You can work with lists of data classes. You can work with pandas data frames even, and more. Again, just refer to the documentation. It's linked at the top of the notebook and the repo. So let's see how it handles dictionaries. So I'm just going to copy paste this code from the notebook. Basically, it's just a little bit of data, and it's a dictionary. And you can see that the dictionaries don't all contain the same keys. Here we have A, B, and C, but this one has B, C, and D. So we have some overlap sometimes, but sometimes we have some missing and so on. But Tabulate is going to be pretty smart about it. Let's go ahead and just try Tabulate and just pass it D. Let's see what happens. So as you can see, we have these organized as columns. And if you notice, like 1 and 100 are lined up because A was 1 and A was 100. There was no A in the second one, so that's a blank. So you can see that it's intelligent about figuring out how to line things up. But of course, you'll recognize that the only way it can do that is by essentially loading the entire data into memory. That's what it does with the CSV file as well. Here, it's very obvious that that's happening. So how do we specify the headers? Well, it's very simple. We go to Tabulate and we specify headers, just like we did with the CSV file. But now we don't use first row. We don't have our custom headers here. I'm going to tell it to use the keys of the dictionary as the column headers. And so the string constant that we have to use here is keys. And when we do that, you can see it actually labels the columns appropriately based on the keys that were in the dictionary. So there's quite a few more options available, in particular for controlling column alignments if the defaults are not sufficient. I rarely use this because the defaults have always worked great for me. Let's take a look at this example. I'm going to take this data over here. So now I've got some custom headers and I've got data as a list of lists. Now you can see that I have a string here which contains a float, 3.14. Here I have a float. Here I have another float. Here I've got an integer. Here I've got integers, positive and negative. Here I've got strings of different lengths. Okay, so it's kind of a little bit all over the place. Now let's go ahead and tabulate this and let's see what Tabulate does with that. So we'll tabulate data 2. We'll say headers equals headers. And then we're going to specify the table format and we'll make that, let's say, a fancy outline. I kind of like that one. And let's see what it looks like. So you can see that even though that 3.14 is a string, it really considered, in terms of the alignment, it considered it to be a float. And look how it aligns floats based on the decimal point. And you can see that even though 1 is an integer, it was still able to align it, just like with the string, based on the float representations of everything. You can see how the integers here are all right aligned by default, and the strings are all left aligned by default. So the defaults are pretty intelligent and work really well usually. And that's it. That's the Tabulate library. Wonderful library, very easy to use. I use it frequently to generate markdown tables. Sometimes if I need to output, a data report of some kind and I need to generate a table with some data, then I very often use markdown because that's very easy to generate. Tables are not so easy to generate in markdown, so I use Tabulate. Much easier. All right, thanks for watching.